Now, here's a little bit of a twist. Some sequences are defined by a recursive definition, one in which each term after the first term or first few terms is defined as an expression involving the previous term or terms. All right, so basically what a recursive sequence is basically if you have your terms in the sequence, okay, if you pick a specific term in the sequence, it depends on one or more of the prior terms, okay? So in example 2, we're going to look at a couple of recursive definitions, okay? So the directions here say to find the first four terms of the sequence, okay? It's pretty easy to spot a recursive sequence from the formula, okay? Because there's going to be more information given. So in part A, okay, you've got to be able, when you're doing this, you've got to be able to understand and read the notation, okay? You're told here that A1, the first term of the sequence, is 5, okay? You have to have a place to start, okay? Notice in the other sequences, that was not given, okay? You just had a formula, but here we're actually being told the first term. Then an, the nth term of the sequence, is generated by doing a subscript n minus 1 plus 2n. Okay, and then you're told that n has to be bigger than 1. Okay, so that looks like a lot. Okay, but like I said, you really, really have to be able to read notation here. That's important. Okay. All right, well, the good news here is we want the first four terms of the sequence. We already know the first term because we were given it. Okay, so the first term of the sequence is 5. Okay, so we need to start out by finding A2. Okay, so if we want A2, we need to let n equal 2. Okay, so go to the formula here. Okay, and this piece right here, that condition is just telling you that the formula for an applies for n values counting numbers bigger than 1. Okay, so don't worry too much about that. All right, go to your formula. Everywhere you see an n, plug in 2. Okay, so a, the subscript is n, so it's going to be a2. That's going to equal a subscript n minus 1, so that's going to be 2 minus 1 plus 2 times n is 2. Okay, write everything out. You're less likely to make a mistake. So this is going to be a. If you simplify the subscript here, it's going to be a 2 minus 1. That's going to be a1 plus 4. Okay, so this is saying to get the second term in the sequence, you need to take the first term, a1, and add 4. Okay, a1, we know that that is 5, so add 4 to it. So the second term in the sequence is going to be 9. Okay, so the second term depended on what the first term was. Okay, now let's get the third term. Okay, so bump it up. We need to plug in n equals 3. Follow the recipe. Okay, so everywhere you see an n, plug in 3. A3 is going to be a n minus 1 is going to be the subscript, so that's going to be 3 minus 1 plus 2 times n. N is 3. Okay, simplify. Okay, you've got a, the subscript is 3 minus 1, which is 2, plus 2 times 3, which is 6. Okay, this is saying take a2, which is the second term. The second term is 9, and add 6. So the third term is going to be 15. Okay, the third term depended on the second term. The second term depended on the first term. Okay, this is what a recursive sequence is. Okay, The direction said to get the first 4 terms, so we need to find one more. So now let's let n equals 4. Plug into the formula. Everywhere you see an n, put a 4. So here we go. an, so that's going to be a4, fourth term, is equal to a. The subscript is going to be 4 minus 1, or n minus 1, plus 2 times n, which is 4 here. So if we simplify on a, 4 minus 1, the subscript on a is going to be 3, plus 2 times 4 is 8. Okay, so this is saying to get the fourth term in the sequence, we need to take a3, the third term, and add 8. So this is going to be 15 plus 8. Okay, so this is going to be 23. Okay, so there are your first 4 terms of this recursive sequence. Okay, so it's going to be a1 is 5. We were given that. And then we computed a2 is 9, a3 is 15, and then a4 is 23. You could keep going. Okay, but again, a recursive sequence, okay, what that means is that if you take a specific term in the sequence, it depends on one or more prior terms. Okay, all right, let's try another one. All right, in part B, okay, again, we just need to get the first 4 terms of the sequence. We are told that the first term, a1, is 1. We're told that the second term, a2, is 3. And then there's a formula for computing future terms, okay? So the reason that we're given 2 terms here, okay, if you look at part A, we were only given the first term, but now we're given the first and second term, okay? In the recursive definition, it's going to involve more than one prior term, okay? So like what you'll see is that to get the third term, it's going to involve the first term and the second term, okay? Just follow the recipe, okay? We know a1, we know a2. To get a3, we need to plug in n equals 3. Go to your recursive definition, which holds as long as your n value is 3 or bigger. Pop in n equals 3 everywhere you see n. Okay, so an, so that's going to be a3, the third term in the sequence. We get that by doing a, the subscript is going to be n minus 1, so that's going to be 3 minus 1, plus another a. The subscript this time is going to be n minus 2, so that's going to be 3 minus 2. So if we simplify here, this is going to be a. The subscript is going to be 3 minus 1, which is 2, plus, simplify the other a. The subscript is going to be 3 minus 2, which is 1. Okay, so what this tells us is to get the third term in the sequence, you need to take the second term and add the first term. So a2 is 3, a1 is 1, so add those guys together. The next term in the sequence is going to be 4. Okay, so let's try the next one. We only need one more term. Okay, to get the fourth term, we're going to let n be 4. Okay, go to your formula, pop in n equals 4 everywhere you see an n. Okay, so read the recipe. an, that's going to be a4, the fourth term, is equal to a. The subscript is going to be n minus 1, so 4 minus 1, plus the next a. Okay, the subscript on it is going to be n minus 2, so 4 minus 2. Okay, simplify. This is going to be a. The first subscript here is going to be 4 minus 1, which is 3. We're adding the next a, which has a subscript of 4 minus 2, which is 2. So this tells us to get a4, you have to take a3 and add a2. Okay, so you get the fourth term in the sequence by adding the third term in the second term. Okay, we know a3 is 4. We just computed that. That's right here. And we know a2 because it was given. Okay, so a2 is going to be 3. Okay, so that's 7. The fourth term in the sequence is going to be 7. Okay, We weren't asked for the fifth term. I'm just going to go ahead and find it just to make sure you're getting the hang of this. Okay. If I want the fifth term, I'm going to let n equal 5. Okay. Follow the recipe. So now n is going to be 5. So A5, the fifth term is going to be A. Okay. The subscript here is going to be n minus 1. So it's going to be 5 minus 1 plus A n minus 2, so that's going to be plus A, the subscript is going to be 5 minus 2. Simplify to get the fifth term, you're going to get A, the subscript is going to be 5 minus 1, which is 4. So A4, the fourth term, plus A, 5 minus 2 is the subscript, so A3. Okay, so again, what we're seeing here, to get a certain term in the sequence, we are adding the two terms that came before it. To get A5, we have to add A4 and A3. A4 is 7, and then the third term in the sequence is 4. Add those two guys, the fifth term is going to be 11, okay, and so on, okay. So I'll go ahead and write down these first few terms that I found. I found one extra than I should have, but the sequence starts with a term of 1. First term in the sequence is 1. Second term is 3. Those two guys were given. And then we use the recursive definition to get the third term of 4, the fourth term of 7, the fifth term of 11, and you could keep going.